All right, let's look at the homework 3.9, problem number 4. All right, so let's solve this boat problem. All right, so we have a boat, and I think there's a pulley, and this is 1 meter higher. So this is 1 meter right here, higher than the boat here. So we're gonna have a right triangle there. All right, then the rope is pulled at a rate of 1 meters per second. So it's pulled in at 1 meter per second. And how fast is the boat approaching the dock when it is 7 meters from the dock? So at that time, so this is 7 meters. All right, so let's give variables to the changing quantity. All right, so there's a length of the rope is changing. So I'm going to give, say, R, since it's a rope, R. All right, and the distance between the boat and the dock would be, I'm going to call it maybe X. All right, so since we have a right triangle and we need an equation relating X and R, so I'm going to use a Pythagorean theorem. So by Pythagorean theorem, we have, so Pythagorean theorem, we have, let's see, x squared plus 1 squared is equal to r squared, right? And what are the given values? Let's see, we have, so here, R is changing at the rate of 1 meters per second since the rope is pulled in at that rate. So we know that the dr over dt is equal to, it's going to be -1, right? So -1 because it's pulled in, right? And also x value at that moment is given to be 7, right? And I think that's about all it's given, right? And then actually we can find R value too. So R value is going to be equal to, right? So using the Pythagorean theorem, so it's going to be a square root of, right? So we have to take the square root. So it's going to be 7 squared plus 1 squared. So this is going to be square root of 49 plus 1. So it's going to be square root of 50, right? So I guess we can pull out 5, and this is square root of 2, right? So we have that. Then what we're looking for is dx over dt. So dx over dt. So this is what we're looking for. All right, so we're going to just go ahead and take the derivative of this equation here. So I'm going to take the derivative with respect to t. All right, derivative of x squared would be 2x times dx over dt. And derivative of 1 is 0, so I'm not going to write anything down. And derivative of r squared would be 2r, then d times dr over dt. All right, so remember that we're looking for dx over dt, so I'm trying to isolate that. So I'm going to divide through by 2, and so it cancel 2 here and cancel 2 there. Then I'm going to divide through by x. So divide through by x. So dx over dt that we're looking for is going to be r over x dr over dt. All right, so this is going to be equal to, so r, we just found that to be 5 square root of 2, right? X is equal to 7, right? And dr over dt is -1, right? So we have, this is negative 5 square root of 2 over 7. All right, so let's compute that value. So I'm going to just bring out a calculator. All right, so it's going to be -5 times the square root of 2. Let's see, where's the square root? Here's the square root of 2. And then divided by 7. So divide by 7. All right, then we have 2 decimal places, so it's going to be negative 1.01. So this comes out to be negative 1.01. All right, so let's type it in. All right, so let's see. We have, so we're looking for if the rope is, so how fast is the boat approaching? So we don't need to put the negative sign because it's approaching at that rate. So I'm going to just type in 1.01. So 1.01. All right, so let's check the answer. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.